Hi folks, this is section 4.4, number 21. This is a long problem. It has a lot of tricky algebra in it and also some domain restrictions as well that I want to make sure to mention. So we have this f of x, and whenever you have a fraction, we know that numbers that zero out the denominator can't be included because they're not part of the domain. Same thing happens for a radical. We have a domain restriction. Notice if you put -3 in there, it'll be the square root of 0. And that's the highest value that a square root can take. So we have -3 to infinity is what you can plug in so that you get values in the square root that are 0 or greater. So we need to find concavity, concave up, concave down. And so we're going to find the first derivative and then the second derivative. And we're going to simplify after the first derivative to make sure that we can take the second derivative easily. And so let me rewrite it. Yeah, I think I'll rewrite it first. So let me just change this back to say f of x and rewrite. And then that'll be x times x plus 3 to the 1/2 power. And then my f prime of x, I'll need the product rule, is equal to first times derivative of the second, 1/2 x plus 3 to the -1/2. The derivative of the inside is 1. Plus the second, x plus 3 to the 1/2 times the derivative of the first. And so I've got a denominator. If you have a negative exponent, you have a denominator. And we also have two terms. So here's a term, and here's a term. They're separated by this addition right here. So we're going to take the greatest common factor out of each term, and that'll grab our denominator, our negative exponent. Because when we factor, we want to factor out, it's still f prime of x, we want to factor out x plus 3 because that binomial is appearing in both, and we also have to take care of the negative exponent. That'll do it. And we take out the lowest power. So -1/2 is the lowest power. And to find out what we get from doing that, we rewrite the original. And we divide by the same thing that we're factoring out. And in the first term, it's going to cancel. So we know x plus 3 -1/2 is same on the top and bottom, and so that works out really nice for us. In the second term, you're subtracting the exponents. Your exponent is going to be your top exponent minus your bottom exponent. So it's 1/2 plus 1/2, which is 1. So that'll become x plus 3 to the 1. So therefore, we have f prime of x. This is a denominator, so it's going in the denominator. It will no longer have a negative exponent. The numerator, then, what we have left is 1/2 x plus x plus 3 to the 1 power. And now we can combine like terms. And this is equal to 3/2 x plus 3 over x plus 3 to the 1/2. And in your textbook, your authors, man, they like to really mess with you here, I think. I think they just really do some tricky stuff without explaining it sometimes. So here's the trick that they're doing. They're not liking this fraction, and it is a little funny looking as a coefficient of the x. So they're going to multiply by 1 to get rid of it in the form of 2/2. So that's 1, meaning I won't change the value if I multiply by it. And it distributes. So when you multiply here, that 2 in the denominator will cancel with this 2. So now your f prime of x, the first term in your numerator, is going to be 3x. And then you distribute it here, and you get plus 6 over. And then you have to multiply it in the denominator. So your denominator gets slightly more complicated, but not by much. And so that's what you'll find that they've done if you go to CalChat. Moving up. So that's our first derivative. Now the second derivative. And we want the quotient rule. So low, 2 times x plus 3 to the 1/2. D high, 3. Minus high, 3x plus 6. D low, 2 going along for the ride, bring the exponent forward 1/2. That works out well. Rewrite the base x plus 3. Take 1 off the exponent, negative 1/2. And the derivative of the base is 1. All over low, low. So careful here. 2 times x plus 3 to the 1/2. All of that gets squared. So the 2 gets squared, and then the exponent will multiply 1/2 times 2. So now we have to do the same thing again. We have a negative exponent, and you can't just pop it down because your numerator is not factored. You can only do that with factors. And so we're going to have to factor. And to factor, we're going to take out the x plus 3, and we're going to take out the lowest power. So factor again. Same situation as before. So it's still a second derivative. And we're going to take out an x plus 3. And we're going to take the lowest power of it, which is negative 1/2. To figure out what we have left inside, we'll rewrite the original. Let's clean it up this time as we go. So this is 6 times x plus 3 to the 1/2. And if you don't need to rewrite it this way, you can just factor it out like you're used to as well. And then over here, we're going to have minus. The 2 and the 1/2 cancel. And so we're left with 3x plus 6 times x plus 3 to the negative 1/2. And we'll divide by the same thing we're factoring out. So x plus 3 to the negative 1/2. X plus 3 to the negative 1/2. And to find out what you get for your new exponent, you subtract the exponents. So we have, oh, I need my denominator. This denominator here is 4 from 2 squared times x plus 3. Moving up. So now f double prime of x is equal to, let's move this guy down. So our denominator is now 4 times x plus 3 that we had before. And then we have an x plus 3 to the 1/2. And we'll be adding the exponents for those. Inside our parentheses, the exponents being subtracted, it's 1/2 minus negative 1/2. So you have 6 times x plus 3. And because there's no exponent on there besides 1, you can now distribute. If there were any other exponent, you couldn't. And then the next term, the x plus 3's to negative 1/2's cancel. So we have minus 3x plus 6. So still some cleaning up to do. We'll distribute. We'll combine like terms. Let's distribute the minus while we're at it. So f double prime of x is equal to 6x plus 18 minus 3x minus 18. Ah, nice. And then we're going to have 4 times x plus 3 to the 3/2 power. Okay. Oh, where did I get that minus 18? This, I think, is wishful thinking. This should be negative 3x minus 6. Glad I caught that when I did. Something was not feeling right. Okay, so now we have 3x plus 12 over 4 times x plus 3 to the 3/2. And we're going to set equal to 0 and set equal to 0. To find out where the second derivative is 0, you set the numerator equal to 0 of a fraction. That's where fraction 0. To find out where the second derivative does not exist, you set the denominator of the fraction equal to 0 because that's where a fraction does not exist when the denominator zeroes out. So the numerator, 3x plus 12 equals 0. Subtract 12 and divide by 3. And we get x equals negative 4. And then the other one, we have 4, the denominator, times x plus 3 to the 3 halves equals 0. Divide by 4. X plus 3 to 3 halves equals 0. Do the, well, I guess I can do it that way. You can really raise it to the 2/3 power. So that would be the cubed root squared. And if you do the same thing here to the 2/3 power or the cubed root square, your power is gone. So this just leaves us x plus 3 equals 0. And when you subtract 3, you get x equals negative 3. So both of these are possible inflection points as long as they are in our domain. And if you go back and look, our domain is from negative 3 to infinity. We can only use values in there. Those are the only ones that we care about, and they're the only ones that make sense. So x equals negative 4, we don't use it. It's not in the domain. So when you break this up, you're going to go from negative 3. There's your possible inflection point, and it really can't be because it can't change on either side because you have nothing on the left side to use. So you're really just testing the interval from negative 3 to infinity. And you can use 0 there, and you can test that, and I'll leave that for you to do, but, well, it's really not that hard because we've got the second derivative here, so I guess we can do it together. The second derivative evaluated at 0 is equal to, if I plug 0 in the numerator, I'm going to get 12. If I plug 0 in the denominator, well, I'm going to have some number that's irrational, but it's positive. So I know that my second derivative is positive, and that means concave up from negative 3 to infinity. All right, that was a long problem, but hopefully it made sense. Hopefully, you know, this weird stuff over here where they multiplied by 2/2, it did make things a lot easier. I had done this problem before, just leaving it as a 3 halves x plus 3, and it was pretty messy looking. So if you want to, you can multiply by 1 anytime you want, because the multiplicative identity tells us that if we multiply by any form of 1 at all, it doesn't change the value. And in fact, sometimes it just makes things a little bit easier to work with. So have a great day, and let me know if you have any questions.